everyone, my name is Nurfaraliyana Binti Samburi, electrical student in Universiti Tun Hussein on Malaysia, and my supervisor's name is Dr. Ahmad Fateh bin Mohamad Noor. My title for this project is Voltage Stability Analysis of Electric Power Systems with High Penetration Photovoltaic Integration.
Energy demand has increased as people use electricity for various purposes. The graph shows that the energy demand has increased due to the population growth. Thus, it poses a challenge to non-renewable sources like fossil as they will deplete and cannot be replaced. We depend on them to supply our energy. As a solution to the energy availability issue, a solar PV has been introduced. Increasing the load demand will affect the stability of the system because the power system operates closer to its stability limit and can potentially lead to voltage collapse if not managed properly. Therefore, it is necessary to conduct the analysis to identify which one of the weakest load bus. Next, identify weak load bus within the power system where the voltage value is lower compared to other buses. Thus, installing a solar PV at the weakest load bus because solar PV can support the maximum value of active and reactive load.
Firstly, perform voltage collapse proximity index on 30 bus test system. Next, install solar PV at the weakest load bus. Lastly, evaluate voltage stability after installing a solar farm.
The novelty of the project, the increasing human population lead to a rising demand for electricity. The major problem that could occur during this time is the blackout in the distribution area. Therefore, it is necessary to conduct an analysis on 30 bus test system to identify the weakest load bus in the system. Use a VCPI as a tool for analyzing the voltage stability and install solar PV at the weakest load bus because the available surface area is often limited. Benefit, by conducting this analysis, the designer was able to identify the weak load bus and connect them to a solar PV to address the potential voltage stability issue. Next, increase the reliability of the power system by replacing the blackout issue for the consumer and promoting the environmental sustainability, which will provide benefit for the future.
Project has commercial potential for power system researchers and offers consultancy service to power utilities and energy companies. Following the information in the book regarding the 30 bus test system.
This is the code for power flow analysis initially from MathWorks. Was modified with adjustment to all parameters. I already modified to bus data and line data informations, aligning it with the 30 bus test system based on the information from the reference book. This is the result obtained from the power flow analysis. As we can see here, the lowest voltage magnitude at bus 30 measuring 1.006 per unit, while the highest voltage magnitude at bus 12 measuring 1.073 per unit. Take the voltage for each bus and perform the VCPI calculation to identify the weakest bus in the system.
Calculate VCPI by using this formula. The table displays results obtained from the VCPI calculation. To enhance understanding, analyze the results using a graph.
30 can be identified as the weakest load bus due to its highest VCPI values. Writing the result, if the VCPI value below than the 1.0 per unit indicate that the stable system operation, while VCPI value close to 1.0 per unit indicate that the system is at a risk of the voltage collapse. Actually, the voltage magnitude at bus 30 is close to 1.0 per unit. After conducting the VCPI analysis, it results in the voltage instability due to its highest VCPI values. Instead of depending on voltage stability, it is recommended to perform the voltage stability technique for a comprehensive analysis. Conducting the VCPI analysis proved useful in identifying the voltage stability concerns. To address the issue, bus 30 will be connected to a solar PV to achieve the steady-state voltage stability. As a result, the voltage stability increases as the maximum active and reactive load expand to a larger solar PV installations.